So we're going to look at an example of inference attack with the database that was defined by the schema that we just discussed. Query that we're going to consider here is a query that returns the average score on an exam. Okay, so any student should be able to find out. In fact, that's like the first question after an exam. When you bring back the grades, students ask what was the average. So any student should be able to submit a query that returns the average of the score on that exam. And the average basically is we take every student's grade, sum it up, and then divide it by the number of students. And that shouldn't tell us anything about a particular student. Remember, what you're not authorized to access is somebody else's grade. This is an authorized query, and our idea of inference attack is that you're going to use a query like this to gain access to information that you normally are not allowed to see. If you're an attacker, your goal would be to gain access to information that is not available to you. So that would be to find the exact score of some other student. It's not your score that you already know, but if you are an outsider, of course, you're targeting a particular student and you want to find out his or her exact score. That's the goal of the attacker, or the information that we want the attacker to get access to. Inference attacks sometimes require some additional outside or external information. So maybe the attacker does know when some person takes the exam late. Could be because they were sick or something like that. So the whole class took the exam on a certain date, and after a few days after that, perhaps the student is going to take the exam. And this information is available to the attacker. So what the attacker is going to do in this case is run the average score query before this one student, the one who takes the exam late, actually takes the exam, and his or her score is added to the database. So before the exam is taken, the score may be 0 or something like that, and after the exam it's replaced by the correct value. So the attacker is running the average query, which we said should be allowed before this one student takes the exam. And the attacker knows when the student has taken the exam, maybe tries a few times, eventually sees maybe a different average value. Or after a certain amount of time, we know that the exam must have been taken by everyone, including this one student who had missed it earlier. So it does the average again. Okay, so now I have two averages. Let's say this student is Alice. So the average score not including Alice, and then average score of everyone that includes Alice. Well, based on these two values that are returned by this query that is allowed, I can now figure out what Alice's average is. Actually, it's fairly easy to do that. If there are n number of students, the total score, if you add them all up, is n times the average. So here, since Alice hasn't taken, so it'll be n minus 1 times the average is the score before, the total of the scores before, and this is after Alice takes the exam. The difference is Alice's grade exactly. Okay, so the idea here is that these two queries both are allowed because they return the average. The database system allows the attacker to run each one of these queries. By running these queries at particular times, you have to think through when exactly you want to do that. We are able to make an inference and find the exact value of the target score just by the difference that I just mentioned. So this is the example of an inference attack where you use authorized queries to gain access to information that you're not authorized for, so which is the exact score of the target. In this case, the target was Alice.